Let's solve few problems based on the topics, whatever we have discussed so far. See, we have discussed two types of, problems or two topics basically. Okay, the first entire part, whatever we discussed is about the signs of trigonometric function and allied angles. Okay, this is the first part what we have done. All right, so the entire thing, whatever we have done, so based on that, first we'll solve one type of problem. Okay, look at this one. Find the values of the following. So in this, they have given 4 questions. Let's start the first one. Sine of minus 315 degree. Now, one thing here, it is quite an important part. Whenever we have sine of minus theta, you can write this as minus sine theta. Okay, so this you can put it in a box and you can put a star because this is quite an important part. Suppose if you have cos of minus theta, it is just cos theta. This also, it's a very important part. So please put it in a star. Okay, so this is one basic thing. Because once you have sine and cosine, you can take tan, secant, you can figure out every other trigonometric function, correct? So this particular type of problem is where we are going to get the values on different quadrants. Okay, so here we are using the concept of allied angles. So pay attention. See, for the first one, sine of minus 315 degree. So when you have sine of minus 315, we can write this as minus sine 315. 315 lies in which quadrant? First point. It is going to lie in the fourth quadrant, correct? Because from 270 to 360 is the fourth quadrant. Sine in the fourth quadrant, is it positive or is it negative? It's negative, correct? So what we are going to get here, we are going to have minus sine of 360 minus 360 minus how much is 315? 45, correct? So 360 minus 45. Now, if you look at the allied angle table, sine of 360 minus theta is minus sine theta. So we are going to have minus of minus sine 45. So what do we get? Just sine 45. And sine 45 is how much? 1 by root 2. So the value for the first one is going to be just 1 by root 2. This is how you solve. Fair enough? Now let's do the second one, which is in terms of pi. It's given in terms of radian measure. We'll look into that one. Okay, so let's do the second one now. See, for the second one, what you have, cos of 17 pi by 4. Okay, now it's very important to understand that 17 pi by 4 lies in which quadrant? First, second, third, fourth. Okay, now for this, how much is pi by 4? Always we'll start with that. So first, pi by 4, this is going to be 180 by 4. 180 by 4 is 45. So pi by 4 is 45. 17 pi by 4. So let's make a simple, quick sketch of how it might look. See here, this is 45 degree, correct? So this is 1 times 45. 90 degree will be 2 times 45. This is 3, 4, 5, 6, 7, 8. That means 360 degree is 8 times 45 or 8 pi by 4. Here we have 17 pi by 4. That means the next is going to be 9, 10, 11. So far and so forth. How much will this be? 8, sorry, 9, 10, 11, 12, 13, 14, 15, 16. So 16 pi by 4 is the same as 0. Correct? So 17 pi by 4 is going to be the next case, which is going to be the third case here. 17 is going to be here. Now, we can't do this everywhere, isn't it? It's not possible. So there should be a mathematical way. For that, what we do, 17 pi by 4, subtract 2 pi, because 2 pi is 360. What are you going to get? 17 pi minus 8 pi by 4. 17 minus 8 is 9. So 9 pi by 4. Further subtract. That means 9 pi by 4 minus 2 pi, which is 9 pi minus 8 pi by 4, which is pi by 4. So cos of 17 pi by 4 is the same as cos pi by 4, because if you remember the allied angle table, cos or any trigonometric function, 2 pi plus theta is the same as theta. That means cos of 2 pi plus theta is going to be just cos theta. So what do we have here is that cos of 17 pi by 4 is the same as cos of pi by 4, which is 1 by root 2. So for the second one, answer is just 1 by root 2. Now, if you can't do in terms of radian, there is another way. Just convert into degree. Convert to degree in the calculation column. Convert to degree. Then you'll figure it out. Okay, it's more than 360. So once you are comfortable with radian measure, then you can solve in this particular method. Fair enough? Let's do the third one. Third one is again in terms of radian. Let's do the third one. See, the third one, you have cot of minus 13 pi by 4. Again, we have a pi by 4, correct? Cot of minus theta is minus cot 13 pi by 4. Now, this one, let me show you, how we can do it with conversion to degree, so that, it's easier for you to do it. This is going to become minus cot 13 into 45. Correct? 13 into 45. So 13 into 45 will be, you'll get minus cot of 585 degree. See, from radian, we converted to degree here, correct? So 585, it's more than 360. So first what you do, you subtract by 360 degree. Okay. So 585, so here we'll do quick calculation, 585 minus 360. So how much you'll get here? So you're going to get 225. So this way, minus cot of 360 plus 225. How much is cos of 360 plus, cot of 360 plus theta? Cot theta itself. So this is going to become just cot of 225. Now 225 is in which quadrant? Third quadrant, isn't it? Since this is in the third quadrant, cot, is it positive or negative in the third quadrant? Cot is positive, right? Third quadrant, AST, tan and cot are positive. So this case, this is going to become minus cot of 180 plus 45. See, 180 plus 45 is 225. So this we can write it as minus cot 45. How much is cot 45? 1. So the answer is going to become minus 1. This is going to be the final answer. So for the third one, answer is negative 1. Okay. See, the second one, we use just radian, we calculated. Third one, we converted to degree and we calculated. Both of them are correct. Okay, both are correct. But I recommend you guys using a radian measure, because radian is much more important. All right. So let's do the fourth one, which is already given in terms of degree. All right. For the fourth one, tan of 450. First thing, subtract 360 to figure out how much is it exceed, like what is the offset. All right. So when you're doing this, 450 minus 360. So 45 minus 36 is 9. So what do we have? Tan of 360 plus 90. So tan 90. What is tan 90? This is going to be not defined. This is the answer for the fourth one. Clear? So four different types of problems, correct? All of them are finding the value. One is based on negative angle, one is based on radian, next is radian to degree conversion. So different types of problems. Fair enough. So this is one type. So next we'll go and see the next second type of problem in this one. All right. See, this is the second type. Here, find the other trigonometric values. Now, given question C, tan x is 1 by root 3, lies in the third quadrant. Okay, since this is in the third quadrant, we need to understand that the rest of the values are going to be negative. Remember, sine is positive in the second, tan is positive in the third. That means sine, cos, and their reciprocals, all of them are going to be negative. Correct? So first what we'll do, if you have tan x is 1 by root 3, okay, this is in third quadrant. So what we'll do, we can say that tan of x is equal to 1 by root 3. Since this is in third quadrant is what? 180 plus theta, correct? So we are going to have 180 plus some value theta. This value is nothing but 30 degree. Now how do we get 30? What is tan 30? 1 by root 3. Correct? 1 divided by root 3. Now here we can say 180 plus theta is equal to 30. This way we can figure out the value of theta. Okay, but you might be thinking, I can clearly say theta is minus 150 degree. So this is one way of getting the value of theta. There is another way of getting a value of theta. Okay, there is one more way. That means 180 plus 30. Tan of 180 plus 30 is the same as tan 30. So 180 plus 30 is how much? 210. Now you can say minus 150 degree or you can say 210 degree. Both are correct. Okay. So I'm giving you a lot of things to understand. Please take your time and understand, because it takes some time to get used to the allied angles. That's why. So one way of getting is 180 plus theta is equal to 30. That way you will get theta as minus 150, or you can also take 180 plus 30, which is 210. So both of them will give you the same answer. Clear? Anyway, now we have 210 degree. So we'll use the positive value, much more easier. All right. Now, if tan of 210 is 1 by root 3, next cot x will become just reciprocal, which is root 3, correct? Now remember, we are just taking 30 values, like tan 30, cos 30, sin 30, that's all. But with the proper negative or positive side. Okay? Cot x is root 3. Next, we'll go for sin x. Sin x is what? Sin of 180 plus 30, which is just sin 30 with a negative sign, minus half. So same way, cos x is going to become minus root 3 by 2, which I think you guys will understand why we are doing this. Next, cosecant x will become minus 2. Secant x is going to become minus 2 by root 3. So the answers, whatever we have here. So this is one answer, this is one more, this is one more, and this is one. And this is, of course. So the other 5 trigonometric functions what we have in that quadrant are going to be these. These are the values. Fair enough? Same way, we'll do the rest too. The second and the third sub question now. See the second one, we have secant x is equal to 2 by root 3. And they're telling you that it lies in the fourth quadrant. Correct? Now, for what value of secant, you're going to get 2 by root 3 as the value. First, if you know this, it's going to become very easy for you. Okay? So, you can do it two ways again. One is 360 minus theta. So, 360 minus some value theta. This value is equal to. Now, here, secant 30 is going to become 2 by root 3. Correct? Secant 30. That means theta value should be equal to 30 degree, right? So 360 minus 30. 360 minus 30 is what? 330. That means we can say that x value is going to be 330 degree. Once you have the value of x, then we can first thing what you do, find the reciprocal. If secant x is 2 by root 3, then what is cos x? Root 3 by 2. Reciprocal, correct? So first, cos of x is equal to root 3 divided by 2. Basically, we are finding the value of 30 degree. Again, I'll repeat, any trigonometric function, say for example, cos itself. Cos of 360 minus theta is nothing but cos theta. Okay, for all supplementary angles, that is 180 or 360, the trigonometric function will not change. If it is 90 or 270, that means we are taking complementary, then the complementary trigonometric function will arrive. So now, coming back to the problem here, cos of x is root 3 by 2. Next, sin x will take. Sin in the fourth quadrant, it's negative, right? So this is going to become same as minus sin, and here it's going to be just 30 degree. So which is minus sin 330, which will be, I think it's better if we write just sin 330, which is going to give us minus sin 30. This, I think it's much better way of writing. Okay, then tan. Tan of x is equal to minus 1 by root 3. Cot x is equal to minus root 3. Cosecant x is equal to minus 2. So these are the rest 5 trigonometric functions. See the last one, first point you need to understand is it is not a standard function. It's not a standard value. Like 1 by root 3, 2 by root 3, this is not a standard value. Here what we do is, we take the triangle. Okay, you have solved these kind of problems last year. It's going to be the same way. So here what do? We take triangle. Some value theta. Say this is ABC. Okay, so here they're telling x. So let's make this as x. Okay, so let's make theta, will take off theta and we'll write this value as x. Assume tan x is 5 by 12. See, the negative sign is because of the quadrant. The length can never be negative, correct? Now, this is 5, this is 12. Now, according to Pythagoras theorem, this is going to become 13, or this will become 13. Now, what is given to you? Tan of x is equal to minus 5 by 12. What is the first thing you will calculate? Reciprocal. Cot x is equal to minus 12 by 5. Now, in the second quadrant, which is positive, sine, cosecant, right? Now, we'll calculate the sine function. Sine x. Sine x is going to be opposite by hypotenuse. Opposite is 5. Hypotenuse is 13. Next, cosecant x is equal to 13 by 5. Cos x is equal to minus 12 by 13. Finally, secant x is equal to minus 13 by 12. Other rest trigonometric function. See, here we solved two types of problems, correct? One is based on allied angles, which I would recommend you guys solve more and more and more allied angle problems, because you need to understand which quadrant, first case, what sign you have to put, and what is the value of the function. So there are three parameters in that. The second type is where one trigonometric function is given to you, and you have to find out the other five based on the value and the quadrant. These are the two types of problems here, whatever we have discussed. Okay, in the upcoming videos, we'll look into different trigonometric identities, different trigonometric functions, as in multiple submultiple angles, compound angles. There are a lot more things to discover and a lot more things to discuss in this particular chapter. So we'll start that from the next video.